So section 1.1 will begin our ratio and proportions unit. I know that you have studied ratio and proportions before, but this year we're going to get a little bit more in depth. So 1.1 is called Show Someone You Care. Send flowers. And this is the introduction to ratio and rates. In this lesson, you will identify ratios, rates, and unit rates. You will use ratios, rates, and unit rates to analyze problems. Your key terms in your new vocabulary section that you'll need to update are listed here. So make sure you don't forget to update that vocabulary section. I'm going to read this section to you, and I'd like for you to read with me and maybe underline some things if you think you find anything important. So you probably don't think about flowers on a daily basis, but there are some people who do. Florists routinely think about different types of flowers, arrangements of those flowers, ordering flowers, plants, balloons, baskets, and vases, and there's a lot to floristry. But make no mistake, the business of floristry is more than just flowers. It's dollars and cents and mathematics. For example, there are certain days of the year when there's a huge demand for roses, vases, and baby's breath. When this occurs, florists must accurately order roses and baby's breath in comparison to other flowers to make sure they can fulfill the demand, but not have a lot of these flowers left over. What certain days do you think might have a higher demand for roses or vases? How do you think mathematics can help florists order and arrange flowers? Well, I'm assuming that you're sitting thinking about those kinds of days, and I would say probably the number one day to order flowers would be Valentine's Day, with maybe a close second of Mother's Day. These are the days that, flowers are ordered most often because of girls, and girls like flowers. So they have to look at averages over years and throughout the year to figure out how many flowers or how many roses on average people buy so that they can have enough when they go to sell it. So Pat's Flower Shop specializes in growing and selling large daisies. On a typical summer day, you may hear a florist say one of these statements. In the Daisy Smile Bouquet, there are 2 white daisies for every 3 orange daisies. In the Daisy Smile Bouquet, you have 2 out of every 5 daisies are white. 5 daisies cost $7.50, and there are 10 daisies in a small vase. In each statement, the florist is comparing 2 different quantities. In mathematics, we use ratios to make comparisons. A ratio is a comparison of 2 quantities using division. That's important. So let's consider the statement. In the Daisy Smile Bouquet, there are 2 white daisies for every 3 orange daisies. The relationship between the 2 different types of daisies can be represented in several ways. One being drawing a picture or model. So here we have 2 white daisies. Here we have 3. I know they're blue, but we're calling them our orange daisies. These represent our orange daisies. So we have a total of 2 white, we have a total of 3 orange, and a total of 5 altogether. So from the model, you can make comparisons about the different quantities. White daisies to orange daisies to white daisies to total daisies, and orange daisies to total daisies. Each comparison is a ratio. The first 2 comparisons are part-to-part ratios. The last 2 comparisons are part-to-whole ratios because you're comparing one of the parts, either white or orange, to the total number of parts. So a part-to-part ratio talks about parts of the whole. So in this case, we have part of the flower arrangement is white daisies. Part of the flower arrangement are orange daisies. So part to part would be white to orange or orange to white. Now you can write ratios in 3 different ways. So 3 different ways. Before I get to the 3 different ways, I want to touch on part to whole. Part to whole is the other type of ratio, and I'm hoping this is just a review for you. But basically, you're comparing part of what you're talking about to the whole thing. So part to whole includes part of what you're talking about. So 2 white daisies out of 5 daisies total. So that would be part of what you're talking about to the whole of what you're talking about. Now the 3 different ways include using the word to, okay? So you could say, if we're talking about the part-to-part ratio, we would say for this one, we have white daisies to orange daisies. So we could say, oh, we know there's 2 white daisies and then 3 orange daisies. So this is a part-to-part ratio because it has part of what we're talking about and then the other part of what we're talking about, and we're using that word to. Okay? Another way is to use a colon. Okay, so for this example, which is another part to part, we have part of what we're talking about and then another part of what we're talking about. So this time we're talking about orange to white. So we would say orange is 3 and then a colon, and then white was 2. So we have a ratio of 3 to 2 using a colon. The other 2 examples, which are here, it says are part to whole ratios, which we just talked about. A lot of times part to whole ratios are represented through a fraction. So using a fraction is the last way that you can represent a ratio. So in this case, and like I said, most of the time it's part to whole ratios that follow using this fraction model. So for this one, we have white daisies to the total number of daisies. So white would be 2 out of the whole number, which is 5. We have 5 daisies total. So part of it was 2 out of 5 total. And the other one, orange, I'm going to kind of draw arrows. It's kind of getting crowded. We have part, which is orange, 3 out of the total, which is 5. So again, to recap, there are 3 different ways we can use the word to, we can use a colon, or we can use a fraction. Oftentimes, more than not, using a fraction is representing a part to whole ratio. So this diagram here kind of shows you the 3 different ways that you can write it. This says in words, but most of the time it's just using the word to, but you will see it in other ways. So this is representing all the different things that we talked about in fraction form and colon form and in words. So I'll let you read through that. So far we've seen ratios with the same unit of measures. In this case, we've talked about just daisies. However, remember, ratios are comparison of 2 quantities. Sometimes ratios can be a comparison of 2 different quantities with 2 different units of measure. So when this occurs, we call this type of ratio a rate. A rate is a ratio that compares 2 quantities that are measured in different units. The 2 shown statements represent rates. So in our 2 examples here, we have 5 daisies cost $7.50. So remember, a rate has 2 quantities in 2 different units. So our 2 quantities, our first quantity is 5, our second quantity is $7.50. Remember, a quantity is just the amount of something that you have. Our 2 different units are daisies, and then we have dollars or money. So that's how this example is a rate. The second example, we have 10 daisies in 1 small vase. So we're comparing 10 to 1. Those are our two quantities. And then we have daisies to vases. Those are our different units of measure. So write each statement as a rate using colons and in fraction form. So hopefully this is pretty easy for you. I'm going to give you a couple of seconds to do this on your own. So if you want to pause it and then restart it when you have it finished. Okay, so go ahead and check yourself. I'm sure that was fairly easy for you. The next set is a unit rate. A unit rate is a comparison of two measurements in which the denominator has a value of 1 unit. Which statement up here is a unit rate then? Well, I'm hoping that you chose this one. The reason that this is a unit rate is because it has 1 as one of its quantities. Okay. In any size of the daisy smile bouquet, 2 out of every 5 daisies are white. Complete the model for each question using the given ratio. Then calculate your answer from your model and explain your reasoning. So how many total daisies are there if 8 daisies are white? So I would draw, and I'm not going to draw perfect daisies, but I would draw 2, 2, 2. Okay, so we got 1, 2, 3, 4, 5, 6, 7, 8 white daisies. I'm just going to represent these as the others. Okay, so if we have 8 white daisies, how many are there total daisies? How many total daisies are there? Okay, so we know this is 5, 10, 15, 20. So if we have 8 daisies, we know that there are 20 daisies total. Because for every 2 white daisies, we have to add 3 orange daisies. Let's go ahead and check yourself on that one. How many daisies are white if there are a total of 25 daisies? Go ahead and try that problem out. Well, for this problem, you know that daisies come in a set of 5. So if I wanted 25, I need to have 5 sets of 5. So if I draw that out, that would give me 2, 4, 6, 8, 10 white daisies. And all I'm using is my ratio to give me that answer. Because I know that the ratio of white to orange is 2 to 3. I know there are 5 total. So that makes I'm going to have 5 sets total to make 25 daisies. And then 2 out of every 5 have to be white. So then I just count them. You want to explain that in words. The next one, how many daisies are white if there are a total of 35? Well, how many sets would you need? If each set of daisies come in 5s, then how many sets of daisies would you need? I want you to go ahead and pause the video, work that problem out. Okay, hopefully you drew 7 sets of 5, which gives us 35. Remembering that 2 out of every 5 are white. So therefore 2, 4, 6, 8, 10, 12, 14 of these flowers would be white. You need to make sure that you've explained how you figured this out in words. Basically, we used the ratio that we were given and we reproduced it until we had what we needed. That flower shop is giving a one-day sale. 2 daisies cost $1.50. Complete the model for each question using the given ratio. Then calculate your answer from your model and explain your reasoning. How much would 7 daisies cost if 2 daisies are $1.50? Well, we need to extend our daisies. So we have another $1.50 and then another $1.50. Well, right now we have 6 So what are we going to do to get that seventh one? Well, I'm hoping that you're thinking just take half of what a set of 2 daisies cost, which is $1.50. Half of that would be 75 cents. So we know that if I only got one, it would only cost me 75 cents. So $1.50 plus $1.50 is $3, plus another $1.50 is $4.50, plus another 75 cents would give me a total of $5.25. So it's important, I'm not going to write all this out, but you need to explain your thoughts on how you got this answer of $5.25 for a total of 7 daisies as your cost. I want you to go ahead and try B on your own. So how many daisies could you buy for $8.25? I want you to extend out those flowers until you have what you need, and then calculate your cost. I am so sorry, I wrote that problem wrong. So in this case, you are saying you have this much money, how much can I buy? So you're going to draw out the flowers and you're going to add up as you go. So if we have another $1.50, we're standing at $3 right now. If I added 2 more, I would be at $4.50. If I added 2 more, that would be $6. Can I add another? Hopefully you're saying yes. So I had 2 more. This gives me, this is $3. This is $3 more. This is another, that's $7.50. Can I go another $1.50? Well, if I had $7.50 and I added $1.50, that would give me $9. So instead, I might have to just add 1. Well, let's see if we just added 1, which is 75 cents. We determined up here that it would be just 75 cents because that's half of $1.50. And that should give me my total. So we have 2, 4, 6, 8, 10, 11. So if I did $7.50 plus 75 cents, that would give me my $8.25. I'm at my max. So for $8.25, I can buy 11 flowers or daisies, either way. So it's important that you write that out in words. You would say, I was able to draw 11 daisies, and given the rate that 2 daisies cost $1.50. I know that 10 daisies cost $7.50. Then I determine the cost of 1 daisy must be 75 cents because it's half of $1.50. Finally, I added $7.50 and 75 cents to get a total cost of $8.25. All right, problem 3. We have equivalent ratios and rates. Previously, you used models to determine whether ratios and rates were equivalent. To determine when 2 ratios or rates are equivalent to each other, you can write them as a proportion. To determine if they are equal. A proportion is an equation that states that 2 ratios are equal. You can write a proportion by placing an equal sign between the 2 equivalent ratios. Equivalent ratios are ratios that represent the same part-to-part relationship or the same part-to-whole relationship. For example, from Pat's Daisy Smile Bouquet problem situation, you know that 2 out of every 5 daisies are white. So you can determine how many total daisies there are when 8 daisies are white. So we have this is our ratio to begin with. We knew that 2 out of every 5 daisies were white. Then we can multiply by 4 to get 8 white daisies because that's what they were asking us for. So if I multiply the 2 by 4 to get 8, I have to do the same thing to the denominator, which is 5 times 4 to get 20. So that would give us our answer of 20. When you write a ratio to an equivalent ratio, rewrite a ratio to an equivalent ratio with greater numbers, you are scaling up the ratio. So scaling up means to multiply the numerator and denominator by the same factor. So your numbers are going to get larger, but they are still equivalent fractions or ratios. It is important to remember to write the values representing the same quantity in both numerators and both denominators. It doesn't matter which quantity is represented in the numerator. It matters that the unit of measure is consistent among the ratios. So if you're talking about daisies, you want to continue to have daisies. Another way you can write equivalent ratios to determine the total number of daisies are if 8 are white is shown. So basically what they're saying is if I'm given, if I'm given 5 over 2 equals or is equivalent to something, this is our unknown right here. Well, I know that using equivalent ratios or equivalent fractions that I would have to multiply 2 by 4 to get 8. So therefore, I need to multiply 5 by 4 to get whatever number is here. In this case, it should be 20. So use what you already know about equivalent fractions to help you when scaling up different ratios. This also works with scaling down, which we'll get to in just a little bit. So I want you to try a couple practice problems. Number 1 says the daisy smile bouquets are sold in a ratio of 2 white daisies for every 3 orange daisies. Scale up each ratio to determine the unknown quantity of daisies. Explain how you calculated your answer. Well, in this first one, I have 2 next to an unknown value. So white daisies are on top on both. This is important because when you're talking about these things, the units have to match up. So white daisies are on top in both fractions. Orange daisies are on the bottom in both fractions. So in order to figure this out, I would have to say 3 times what gives me 21? Well, I'm hoping you're thinking to yourself that it's obviously 7. 3 times 7 is 21. So whatever I did to my denominators here, I need to do to my numerators. So I would have to take 2, multiply it by 7 as well to give me my unknown number here. So let me rewrite it over here just to hopefully have it make a little bit more sense. So we have 3 times 7 is 21. 2 times 7 gives me my unknown value of 14. So 14 white daisies would be my answer. Basically, to explain yourself, you want to write in words what you did. So I determined that 3 times 7 in my denominator would give me the new denominator of 21. So I have to take my numerators and follow the same process. So 2 times 7 would give me my new numerator of 14. Notice that 2/3 is equivalent to 14 over 21. When you finish scaling up, you want to go back and make sure that your 2 fractions are equivalent. I'm going to let you do B and C to come up with these unknown values. Pause the video, come back, and make sure you have the right answers. So go ahead and check yourself. In part B, I had to multiply by 11, both numerator and denominator, to get my new value of 22. Part C, I had to multiply by 6 on both numerator and denominator to get my 18. And then on D, I had to multiply by 12 on numerator and denominator to get my total of 36 orange daisies. Okay, so scaling down is exactly the opposite of scaling up. So when you rewrite a ratio to an equivalent ratio with lesser numbers, you're scaling down the ratio. So scaling down means you divide the numerator and denominator by the same factor. So for example, you know that 5 daisies cost $7.50, so you can determine the cost of 1 daisy. So if I know 5 cost $7.50, I can divide $7.50 by 5 to get 1. So in this case, I would have 5 divided by 5 is 1. $7.50 divided by 5 gives me that $1.50. So that's where this comes from, $1.50 for each daisy. So scale down each rate to determine the unit rate. So if on number 1 we have 60 telephone poles is 3 miles, I could take 60 divided by 3 to get 20 telephone poles. I put TP there to represent telephone poles for 1 mile. So in both cases, I did 60 divided by 20 60 divided by 3 to get 20, and then 3 divided by 3 to get 1. Oftentimes, what you're dividing by is just whatever's in your denominator for each one. So go ahead and let me do one more with you. So 10,000 people divided by 5 rallies would give me 2,000 people for one rally. So go ahead and complete C, D, E, and F and scale down each ratio. All of these are equal, so therefore they are equivalent. So go ahead and do the rest. Pause the video. Hey, go ahead and check yourself, and then we're going to move on. Okay, so now this is up to you. The talk is next. So you may work with a partner on this if you get stuck, but basically you're going to identify each as a ratio that is either part to part, part to whole, a rate, or a unit rate. Then you're going to scale each ratio up or down to determine the unknown term, and that's all. So I want you to go ahead and complete this part. Again, if you need to talk with somebody through it, or if you need extra help, come get it from me. And then you're to go on and do the skills practice set for 1.1.